Let's talk about what a PV system DC ground fault is in a little more detail. A DC ground fault happens when a positive or a negative current carrying conductor has an unintentional path to ground via grounding conductors, racking, metal conduit raceways or enclosures, a PV module frame, essentially anything that's sufficiently conductive. In my time in the industry, I've never ceased to be impressed by the number of novel ground faults that I come across or hear about. Here's an example of an underground ground fault between a direct buried cable and a bare ground wire. This is a real tricky fault to deal with. But remember, it's not the ground's fault. The ground's just helping us to identify that there is a fault and that there are electrons flowing where they shouldn't be. So what creates that unintentional path to ground and causes ground faults in PV arrays? What we're essentially talking about is failed insulation. It could be insulation on a wire, or it could be the backsheet of a PV module, but it's resulting in a path to ground that shouldn't exist. Common causes include nicked, chafed, or pinched wires, poor installation practices, including improperly rated conductors, thermal expansion and contraction. This could be caused by things like wind or trackers. Exposure to moisture, so if moisture gets into an enclosure with exposed metal parts, or gets into conduits with damaged wires, or damaged or junky modules that just aren't capable of providing the insulation that they should anymore. A really important part of installation and O&M work is being able to identify potential ground faults before they actually become one. Here you can see an example of a wire going over a sharp edge that's likely going to be a ground fault in the future. This should be fixed before it results in a safety hazard or lost production. Not all ground faults are created equal. We're going to use resistance at the fault point to help us categorize them and determine how to respond. There are two categories that we're going to use over and over again throughout the class: bolted or hard faults and resistive faults. Bolted or hard faults are faults that offer little to no resistance and are easier to locate. And then there's resistive faults, which are faults that offer some amount of resistance and may appear to come and go. Because of these qualities, they're generally more difficult to locate than bolted or hard faults. There's another important dimension to ground faults that we're going to use to classify them, and that's whether they're intermittent or not. Both hard and resistive ground faults can be intermittent. What makes a ground fault intermittent is that it's only present under certain conditions. Common conditions that can cause a ground fault to appear or disappear include moisture, movement due to wind and trackers, or thermal expansion and contraction due to temperature. Because they can appear and disappear, they can be really challenging to locate and troubleshoot. But don't worry, we're going to talk a bunch in this class about how to handle them.